Hi everyone, welcome back to this channel. In this video, I'm going to show you how to set up the measurement for spectrum emission mask. As you can see on the screen, I've done something on that setup. Spectrum emission mask is just measurements of your spectrum at different band. It's similar to ACP, adjacent channel power. It is more on the trace and showing you how it looks like on the trace result. Spectrum emission mask allows you to set at different offset with different RBW resolution bandwidth, so that you might be able to capture some spurious, some unwanted signal that's coming out from your channel. You want to make sure that transmitted signal is well within the spec that allows, and also make sure that there's no spurious emitted from your transmitted signal. So right now we have a 64 QAM signal at 4 MHz bandwidth connected to FieldFox. So it's a conducted test. I'm going to walk through step by step on how to set up to the setting that you're seeing on this screen. So let's get to it right now. Let's preset everything so that we can start from scratch again. Preset, mode preset. So make sure that you are in spectrum analyzer mode. Let's set the center frequency to 1 GHz. And let's lower down the span so that the signal is in the middle of the screen. Let's set it to 20 meg bandwidth. So after that, I'm going to set the RBW so that we can get a better reading. Let's go to resolution bandwidth. Escape, bandwidth, resolution bandwidth. Let's set it up to 3 kHz so that you can get a better view of the signal. Or maybe down to 1 kHz because this is transmitted in a cable, so the signal is quite alright. It's not fluctuating like what we have on the over-the-air measurements. So for video bandwidth, I will lower it down further just to get rid of the ripples. There about. Then we set the attenuations so that you get a better SNR, signal to noise ratio. It's not really needed, but it's just for the viewing pleasure. Let's go to scalar reference level. Let's move it up a bit. So assuming that this is the signal that you're looking at over the air, the next step I'm going to do is to measure the bandwidth, the channel occupied bandwidth, then get a gauge of what is the channel power that has been transmitted. So let's go to measure, escape measure, channel measurements, and then let's start with occupied bandwidth. So occupied bandwidth, you need to set the span bigger than the intended signal bandwidth. Let's go to frequency, span, let's enlarge it to 10 meg so that the signal is in the center of the screen with a good roll-out area, and FieldFox is able to gauge what is occupied bandwidth for this signal. So for this signal, we set it about 4 MHz, which is quite correct because you have a 3 dB roll-off over here. So let's set it at 4.4 MHz. Let's keep that in mind. And then the occupied bandwidth power, so it's minus 40. So you have some loss on the cable, so which makes sense. So the next step is, if you're interested, you can go to measure channel measurements, channel power measurements. Before we go to set the integrated bandwidth, we have to set the span to be larger than the signal. So let's go to frequency span, let's set it up to 5 MHz or maybe 10 MHz. Then we set the integrated bandwidth. Let's go to escape, measurement setup, integrated bandwidth, let's set it to 4.4, which is what we got from the occupied bandwidth measurements. So we are looking at minus 40.1 dB at 4.4 MHz. So the next thing I want to do, so most of the setup here are correct. We have a resolution bandwidth of 7.5 kHz, which is quite alright. If you want to change that, just go to resolution bandwidth and go to resolution bandwidth, and let's set it to 1 kHz. So that the signal doesn't fluctuate as much as it should. So once we have that, let's go to measure and go to channels measurements and go to spectrum emission mask. This is where you can find the spectrum emission mask. So you can see there's a lot of information here, and the absolute line and the reference line is way up here. So let's set it step by step. First of all, we want to make sure the total power reference is tally to the channel power that we just measured just now. How do we go there? So go to measurement setup, escape measurement setup, reference channel. So you remember how we set up for the channel power measurements. So the span right now is determined by the offset, the maximum offset. So it's 8 megahertz. So it's left and right. So we have a 16 megahertz. So we can't change the span here, but we can change the reference channel span. So currently it's 5 meg. Yeah, 5 meg should be alright. The integrated bandwidth is the channel power measurements bandwidth. So we set it to 4.4 meg. And from here, I want to change the resolution bandwidth to 1 kilohertz so that it's the same setup as what we see. Okay, so if you remember, we are seeing almost the same identical measurements area around this. Then we're going to set the offset frequency, offset channel measurement. So as you can see, we have 1, 2, 3, 4 here, and we can add in up to the 8th. For this exercise, I'm going to just show you 3. You can definitely add on more if you want to change the resolution bandwidth as it's swept through. As you can see, from 4 MHz to 8 MHz, the integrated bandwidth is 1 MHz. So it's very similar to the resolution bandwidth that you're using. So it's higher noise floor. I can show you later. When there's offset closer to the channel measurements, we can change the integrated bandwidth so that you can see the noise floor changes as well. Right, so far so good. Let's go to setting up the offset frequency. So what we want to do is to get a line here, absolute line down, and then flat line top. So it's pretty much like what you've seen in the beginning. So let's go to offset. So as you can see here, we can turn on 8 different offset. As of now, we have 4 here. Let's go to second and third. Let's go to the 4th and turn it off for now. As you can see, it's removed from the table. And this is how we go about. Let's go to the first one. Let's say I want to measure the 4 megahertz and make sure that there's no rogue signal that exceeds the limit power. And let's start with 0 hertz. So 0 hertz is where it starts from the middle. The whole bandwidth for this channel is 4.4. Let's say to 2.2 meg, because it would take the upper and the lower side band. And we're going to change the resolution bandwidth to 1 kilohertz. That's what we did. Okay, we have done this part, and then for the second part, we want to measure, let's say we want to change from 2.2 to 5 megahertz. We want to see is there any close by sideband spurious that is not supposed to be there, and the resolution bandwidth we might be able to change it to 3 kilohertz because we just want to see the noise floor a bit higher. Let's say from 2.2 megahertz to, let's say, 5 megahertz. So 5 megahertz is the maximum that it goes, so it's 10 meg here. As you can see, it changes over here because of the noise floor. It's different. Let's change the resolution bandwidth to 3 kilohertz. Similar to the reference channel, but a bit higher. But if you want to see it way lower, then you can go further down. Okay. No, that's too slow. Let's set it to 1 kilohertz. Or the other way is I change the resolution bandwidth for the center part so that you can see a big dip inside. Let's say we set it 30 kilohertz. That's what we're seeing. And then second one, 1 kilohertz. So let's turn on the third offset. So let's set from 5 megahertz to 8 megahertz. And you can see the span has increased. So the center part is where the reference channel is. So we set it to 30 kilohertz. And the second part is 2.2 megahertz to 5 megahertz. You can see the noise floor is a bit lower. And then for the third offset, this 5 megahertz to 8 megahertz is 30k, so the noise floor is a bit higher. Let's change back the first channel, the reference channel, to a bit lower, so that we can get a better view of the signal. So that's how we set the trace setup. And we want to see a different offset. It has different integrated bandwidth or resolution bandwidth measurements. Let's set the limit right now. We want to move the absolute line and the reference line into view. So let's go to limit here. Let's get limit. So as you can see, again, it ties to an offset that we set up previously, and we can change the absolute reading or the reference reading of that offset. So in limit, as you can see, we can set the absolute line and so the relative line. So absolute line is the pass-fail criteria, the hard spec, you can call it. The relative line is the relative measurements, the offset from the channel power. So if you set it to -20, so let's say we set it to -20, so you can see the line change because the field mask is set to absolute. So you want to see that change on the relative line as you do. So I would suggest to change to relative or absolute or relative or absolute and relative, so that every time you change the value, you just change on the screen itself. As you can see right now it's -23, so roughly on the line here is about 63, -63 from -40. That is just offset. And absolute, of course, is the one that we're going to set hard spec. So let's say we set it to absolute of -65. So there we go. Yep, or 66. And so if you want a flat line here, what you can do is to set the start at let's say -66 and absolute stop as auto. That will follow what's from the start, so there's a flat line. But if you want to have it in a slope, then you can set it to manual, and let's say we want it to be higher. So as you can see, it will change that way because all this offset is calculated from the middle center frequency and offset to 2.2. So start, stop, and start, stop. For now, I just want to set it to flat line. For that, let's set the second offset. Let's do a bit of a slope. So let's say we start at -50, 65, and maybe a bit lower, just cover that. And stop, I want it to be even lower because I want to create a slope there. So maybe -90. So there we go. And for the third offset, I just want a flat line. So let's go there. And let's do the reference line. So reference start. Let's change the reference down further. Oh, sorry. It's back to absolute, so we can see the change. Let's go there. Yep. So reference, let's go a bit because it doesn't make sense. For relative measurements, you can set up the same pattern with a bit of margin to play around. It depends on whether you want to use the relative measurements because it will shift according to the channel power. Make sense? Because if let's say you're working towards the base station, when you do it, you do not want to change the absolute limit. So you just want to see the limit line changes according to the reference power. So that would be a better choice. Okay, let's set up on the number 3 or so. Let's do this. Okay, so for every offset, you can actually set it separately, absolute or relative measurement, field mask, or you can do then second one you can do absolute and relative measurements. It all depends on what you really want to measure, how you want to measure it. So like I say, the relative measurements essentially change the limit line according to the reference power level. If you're moving a lot, then probably a relative measurement would be a much better choice. So let's do a quick one here. I will mess up the channel offset, the first one, because I want to see a higher fluctuation so that it will be captured here. Yep. So right now that's what we're seeing. Let's focus on that. Scales a bit lower. And because our limit for offset 1 is relative measurements, let's hold it. And as you can see, there's a failure here at 415.8K. So 455.4K. So because our Center frequency is 1 gig. So let's set it to 1.4554 gigahertz. No, that's Mac, sorry. My bad. So it's 1.001 Mac. Yep. Then 4554 gig. Yep. So that's the point that exceeds the limit line here at 61.84. Okay, so this is how you can use spectrum emission mask to create a limit line to do a quick measurements of your transmitted signal. Make sure it stays within the spec and doesn't have any rogue signal that is interfering or is out of spec. Hope this helped. Thanks for watching.